So we're gonna go into some of the questions here. So let's go into the first one. It says, is there a specific waiting time required to get data from HICO, Ocean Color Web, the Coral mission? So for the Ocean Color Web in particular, there's no wait time for downloading HICO data. The entire data archive is available. Remember that HICO in particular was only available for a certain number of years, so that's something that you have to consider when you're doing your analysis, right? And and you can download the data. You can just download a single image, single file, or you can do bulk download options in the Ocean Color Web in particular. And for some other types of data, such as the coral data as mentioned there, there's, I believe, we can verify with the PI of the project, Dr. Eric Hochberg, but I believe they're still in the processing the coral data. It was collected a few years ago, but it's like I mentioned, it's definitely terabytes of data there. So it's going to take a while, probably, for some of it to eventually become available to the general public. All right. Question 2. What tool have you used to plot the correlation between HICO and water quality parameters such as it says CTD, so salinity, turbidity, CDOM, about the degree of alkalinity, pH, salinity. I'm not going to go into alkalinity or pH or salinity because, quite honestly, there's very few, particularly satellite data that covers those different features, and even less hyperspectral data, if there's any. But if you're referring to a particular figure or image on the slides, where there are associated studies links to each slide for you to take a look at. And for instance, level 2 HICO data products from NASA include data layers that display chlorophyll A and KD490, which is the vertical attenuation coefficient, and 490 nanometers, which is a metric for turbidity. The data are derived from algorithms that are similar to those used when deriving the same metrics for MODIS or other multispectral data. They're modified for these particular, some of these particular bands, the more more specific bands. And so make sure to look at those case studies, and if there's a need, you can also communicate with also someone who did this question, and we can provide some links to those studies as well. All right, how are you able to extract question 3? How are you able to extract the different coral spectral signatures? That's a very good question. In this case, and this was the data that I showed was data that I've collected in the field over the years, and in this case, the spectral signatures from corals and other benthic components have we were trained using a handheld field spectroradiometer, which in our case we use a SpectraVista GER 1500, which has been around since the late 1990s, I would say. But there are other brands out there, obviously, of different prices depending on the specifics of the instrument. This particular data was collected underwater. The particularity, I would say, of the GER 1500 is that it has a housing, an underwater housing, custom made by the company, that where you can bring the instrument underwater up to about 150 feet of water, and then the data was collected underwater with the spectroradiometer, as I said. Some data was not shown here has also been collected with the same spectrophotometer that has a fiber optics cable. And for instance, you can bring the samples, coral samples, under the the proper permissions, and to, let's say, an aquarium, and then you can do the spectral analysis there with the fiber optics cable. And then usually it's kind of like a standard procedure for this data collection techniques to have a diffuse panel, spectral panel, um, that it's used to correct for different changes in the atmospheric or water column changes that may have happened during the data collection. For this particular spectral radiometer, it takes maybe a second or two to do one data collection, one spectrum collection. So there's not a big difference there. But if you're collecting, let's say, data over 10 minutes, and you're disturbing the bottom while you're collecting the data, that's something that you have to take into consideration as well. And the spectral panel in particular helps with that, because it has a surface that it's a homogeneous surface all over the panel. Okay, question number 4. Let's see. Okay, Zach, are you out there? Can you help with number 4, maybe 5, since you're more into the demo of the QGIS in particular?
Yeah, sure. So question 4 is, can you tell us more about the conversion of NetCDF format to other formats like GeoTIFF? So a NetCDF file contains a lot of variables, dimensions, attributes, and it can also contain a lot of different layers within that. Kind of like we showed in the demo, you can have a NetCDF file that also includes a layer for, say, chlorophyll or KD490. So they're kind of a complex data file package. And the conversion of NetCDF to GeoTIFF requires that the user choose which variables and attributes you would like to display. So it really kind of depends on what you're interested in extracting from that file as to kind of what you'll pull from that NetCDF and then ultimately convert into a GeoTIFF. So there's a couple of different tools that you can use for this conversion. A couple that we're familiar with are Envy and CDAS. And in CDAS in particular, since that's kind of the free platform that we were using for this demo, it requires that you complete extraction on that NetCDF where you're extracting the layers and information that you're interested in. And then you'll need to either kind of like reclassify or reproject that data to a spatial reference, and then you'll be able to kind of save that as a GeoTIFF. So there's an export feature within CDAS that you should, in theory, be able to use to convert files into GeoTIFF format. There's just a little bit of additional processing that happens before then. And you'll notice Amber's put a couple of links here to some methods of doing this in Envy especially. And if you're interested in doing that in CDAS, I would encourage you to kind of just explore that export feature. And then you can also do some searching on CDAS's website as well, which we have linked in the slides, which has a really nice platform where you can kind of ask questions about how to use CDAS in general. And then we'll go ahead and move to question 5, which is apparently QGIS plugin for hyperspectral data. For example, the spectral library tool, raster data plotting, are not within the list of plugins. Is there any other way of getting the plugin without interference from the QGIS system? So how this works in QGIS is you'll only have the plugins that you've installed directly within your version of QGIS. So when you do that download in QGIS, you'll kind of get like all of the standard tools, all of the standard things about QGIS, but you won't have all of those plugins kind of preloaded. So Amber gave a really nice screenshot here where you'll basically just have to go to the top of your QGIS interface, click the plugins tab, and then you should be able to open the plugins manager, do a quick search for kind of whichever tool you're most interested in. Say that's the spectral library tool. And kind of once you search that, you'll see those various plugins populate. And then you can go ahead and pick which ones you would like to install. And if you look down there in the lower right of the screenshot, there's an install plugin button. And so once you hit that, that plugin will install in QGIS for you, and then you'll be able to use it within the interface.
Great. Thank you, Zach.
Yep.
All right, let's go into question number 6 then. And is there a way to get attributes related to hyperspectral features? Okay. So for hyperspectral, particularly for aquatic hyperspectral data, they're less the freely available spectral libraries are less common. However, you can use hyperspectral imagery to identify a variety of benthic and water quality features, and kind of similar to multispectral. On the algorithms for hyperspectral imagery are used to evaluate water quality, chlorophyll, turbidity, other parameters. and benthic cover mapping may also rely on the application of algorithms or even machine learning. As with our remote sensing, it's always a great idea to incorporate in situ field data or field data for your study area. And this is something that we can't stress enough, particularly for underwater targets. The water column, and I saw a few questions, similar questions that that we're going to see in a moment. But particularly for underwater columns, underwater targets, remember that the water column changes almost constantly. So that is you don't only have the issue with the atmospheric correction, but also the water column correction. This is where it becomes really really important to do to have the underwater data collected either at the same time of the satellite or aircraft overpass if you're dealing with an airborne sensor. But if you can't do it at the same time, as close as possible to the overpass, usually within 1 or 2 hours of the overpass, so that you're sure, or at least you're there's a bigger chance of having a similar water column in the above your, if you're dealing particularly with benthic ecosystems, a similar water column as when the satellite went through, right? Otherwise, you'll be probably comparing two different things, and completely different things, and it's going to be much more complicated. Okay, question number 7 then. You mentioned challenges associated with the drones to collect hyperspectral imagery. Well, I'm aware of some challenges. It'd be interesting in hearing what challenges you're aware of in relation to this application. Probably the ones that I mentioned are probably the ones that our participant also knows, but there's on these days drones are used for collecting data of just about everything. But there are challenges associated with things like platform stability and geo-rectification. The issues with the pitch, yaw, and roll of the platform. Whether, for instance, for water targets, whether it's pointing as a sun or not, if there's sun glint in the image, others. Also, the sensitivity of the sensors flown has to be taken into consideration. As, for instance, in a lot of cases, you're using the commercial off-the-shelf platforms with what comes with them. They usually just come with an RGB camera, and for UUSs in particular, there's a number of new hyperspectral cameras that have been produced, but still their sensitivity, particularly for coastal or underwater targets, is still to be the TBD, to be determined. So there's a lot of ground to be covered, I would say, just to make this to solve some of these challenges that are associated with using drones for hyperspectral imagery. or any other type of imagery for that matter. All right. Question number 8. How do you know when typical atmospheric corrections algorithms are not suitable? So ideally, and another question came later also. Ideally, you will have access to field or in situ data, as I mentioned, collected directly from your study area at the time when, or close to the time of the satellite overpass. That data eventually you can use it to validate the reflectance or other remotely sensed parameters that you want to measure. There's You might be able to find freely available data in the CBAS site, and we included the site there, the link to the site. Um, there was a question about whether also there's a in situ spectral data for some benthic species in particular. You can probably look into that the CBAS site as well, which is a repository for NASA, particularly for NASA funded projects, and it might be there. Also, again, if there's from experience, if there's an advice that I can give you guys is to, if you're able to, with your project, if you're able to get a spectrophotometer or collect your own data, please do, because it's not only going to give you experience on collecting field data and processing it, but also you're sure with that data that you're collecting it from the particular targets that you're interested in. You might also notice that there are image artifacts or a high number of missing pixels in your processed imagery, particularly if the atmospheric correction was not appropriate for your data. Okay. Yeah. This number 9 was not a question, but I definitely wanted to include it here, and because we mentioned PACE, and we want to thank Dr. Erin Urquhart, who's the applications coordinator for PACE, and provided this information. So if you want to learn more about PACE in particular, and its capabilities and how to get involved with PACE applications, please visit the PACE website, which is the link is included here in this particular question. So thanks, Erin, for providing that particular feedback. We always appreciate this from our participants. All right. Question number 10, estimating the absorption maxima for each photosynthetic pigments is possible by calculating the second derivative from the reflectance spectrum. However, there's a shift between the in vitro maximal absorption and in vivo absorption for the same pigment. So does it exist a database to identify the in vivo wavelength for each photosynthetic pigments from the second derivative peaks? The long the short answer is no, that I know. It is very true what our participant is mentioning about the shift in chromatography. That is what is known as a hypsochromic shift, where the absorption features of a particular pigment change during due to the effect of different solvents are used for extracting the pigments, whether you're using methanol or if you're using acetone or something else. And there are two books that I highly recommend if you can get a hand on them, which I've used over many years, and it's one of those that I always refer to when particularly when analyzing HPLC, high performance liquid chromatography data, or reflectance data from from the field in particular, and those two books have an extensive library of spectra from particular pigments. They're aimed at phytoplankton pigments, but as I mentioned during the presentation, it's also applicable to other organisms, photosynthetic organisms that have the same pigments, chlorophylls, carotenoids, and others. Um, and the book shows the where these pigments absorb and how they and in which particular wavelengths. I highly recommend it as a reference, and I've used it over many years. It's the phytoplankton pigments in oceanography book, which was edited by Roy et al. And there are two versions of them, two editions, I should say. And if you can get a hold of both editions, I would recommend it, because there are some pigments that they included in one edition and they didn't include it in the other. So you have a more a more complete data set there if you can get both of them. Plus, there's other references, peer review papers as well on this particular topic. Can you please provide references for water column corrections? So yes, and I'll make sure that when we go the document that's gonna eventually gonna come out in the on the website, to include some of the links to those papers that I mentioned. They're the classic papers of Chongping Li and the classic papers of Kendall Calder and others that have worked on this since the 90s. Water, both atmospheric and water column corrections, and those are very useful, since they provide different ways of assessing water column correction, and they are very specific on the different features and different components of the water column that affect the light absorption. Also, there is how is it called? The Ocean Optics book by Kurt Mobley that is highly recommended. It's freely available online as well, and I will include the links to the Ocean Optics book as well. It goes from the very basic to advanced, different levels. Okay, could you please say something about passive fluorescence? How's it computer some applications? So what I'll mention about this is that there's a usual process that it's very commonly used in the literature, which is to calculate the line fluorescence height, which is a relative measure of the amount of radiance that live in the sea surface, particularly in the chlorophyll emission band, and then uses a simple linear fit between two different bands, that's 667 and 48 nanometers. And it's used to calculate fluorescence, chlorophyll fluorescence in ocean color, and I included the link there as well with more information from the Ocean Color website particularly about the fluorescence line height. Okay, what model was used to collect in situ data shown in the slide? It was a SpectraVista GER 1500. They have a new version of this one. I think it's called the HR 512, and there are a number of others from different companies. We have used this one for about 20 years, and it has served our purposes. The one thing that I can say that I like about them, it has its pros and cons. One thing I can say about it that I like is that since it comes with its underwater housing, you can bring it with you. You can go diving with it and collect the data there as well. And there's a couple of other spectrometers that they have done similarly. So yeah, that's the one we use, but there are others out there, and it obviously depends on your project budget, or depends on the what are the specifics of the questions that you want to answer with your data collection. Okay, slide 8, coral spectra. Is it underwater? corrected from water absorption. The spectra was collected underwater. Well, that's a good question. It was collected underwater with the spectrophotometer that I just mentioned in the underwater housing. But then we use a spectral unpanner to do the correction for the water column in particular. And like I said, it's a standard process uh, for this type of data collection analysis. Is calibration based on ground truth or cross-referencing for other sensors? Yes, it can be done with both. Ideally, again, as was mentioned numerous times, ideally you will calibrate an instrument using ground-based data, your ground-based data during the satellite or aircraft overpass. Comparison of field and average zero water column correction. In that case, which I mentioned, and this is a case that I also mentioned a few months ago when we did the remote sensing for coastal ecosystems webinar. The researchers, and I actually went a little bit deeper into these the details of water color correction during that particular webinar. So I encourage you guys to see it if you have the time. In this case, the researchers at the University of Puerto Rico, the Biooptical Oceanography Lab, they use a series of underwater tarps uh, uh, to correct for water column. This was a relatively shallow site, less than 2 meters. But before and after, when you look at the before and after graphs, you see how even in shallow waters, relatively clear waters in that area, still there's an important influence of the water column that you have to take into consideration when you do the analysis, particularly for benthic systems. Okay. Question 17, we already went over that. So how are you able to extract the different coral signatures? Again, with that spectral radiometers. Spectral radiometer. Question 18, what tools would you advise for atmospheric correction? In particular, how do you manage the aerosol content, which is probably the most variable and hard to determine atmospheric constituent? Yeah, that is a quite complicated question, I would say. And I believe most atmospheric corrections models, they incorporate atmospheric data from the date your imagery was collected to eliminate some of the influences there related to daily variations in aerosols. However, you may have to explore additional methods to minimize the influence of aerosols in your data. And you may need to avoid the use of some pixels also that don't pass a certain quality metric there. So keep an eye out for those image artifacts and exclude any data that appear heavily influenced by some atmospheric corrections. There's also there's an in situ field, a classic instrument that is used for particularly for aerosol collecting data, aerosol optical depth and things like that. Is a microtops some photometer, and it's one of those instruments that have been used for years and years in the field to help particularly with atmospheric correction. Is the hyperspectral data available for the MENA region free? There's a limited amount of hyperspectral data available for that particular region. Since all NASA data is available, freely available, you can take a look and at the spatial extent of data in either the Ocean Color Web or Earth Explorer, Globis, or NASA Earth data, and see if there's any other type of data available for that particular region. Okay, I understand that maybe we can go over a couple more, and then because of the time limitations. But again, we're gonna the ones that we don't answer right now, we're gonna make sure to answer them in the final document. There's a satellite is not necessarily decommissioned at the exact plant date, like for QuickSat. If so, how's the decision taken based on a set of performance indicators? Yes, it depends on how well the sensor is performing and if the data are being used by the community. Generally, satellite sensors last, well beyond their planned date, and generally NASA keeps those sensors in operation for as long as the sensor is working. um, so each sensor likely has a set of their own performance indicators, and if the data are degraded past a certain threshold, then the sensor is eventually decommissioned. Okay, why do average and in situ reflectances diverge more towards a larger wavelength in the visible range? It is because mostly because of the influence of the water itself, absorption in those longer wavelengths, the red and near infrared region in particular. Um, since the number of bands a given wavelength range is several times higher in hyperspectral sensors than multispectral, will the response be more noisy comparatively? Yes. As the wavelength range of this which band decreases, the noise usually becomes larger, and this is why the signal to noise ratio is important to consider with hyperspectral data. Um, okay. All right. Question 23: Is it convenient if any hands-on training processing of hyperspectral data for any component like seagrasses, mangrove, coral, etc.? Do you consider this issue in the session or future? Unfortunately, we don't have any training like this planned at the moment, but we always definitely want to hear more about what types of trainings you guys are interested in. As more hyperspectral missions are planned and successfully launched, I'm sure that we're going to look into holding additional hyperspectral webinars. If this question looks as probably be more applicable to, let's say, an in-person webinar. Excuse me. So whenever conditions come back to normal, eventually. So this is something that we can take into consideration for particularly for a future maybe in-person webinar. Because this is, I mean, if it's hands-on, if it's actually, it's very important to learn how to collect your in situ data, in particular in particular if you're going to use it for validation of satellite or airborne images. There's a number of things that you have to consider, the song angle and the conditions and a number of other factors. Yes, we wish we could do those types of trainings in some areas, but who knows? Who knows? Maybe in the future. Fingers crossed. Okay, probably we can go with this the 24, the last one, and then we'll do the rest offline, and then we'll make this available for the benefit of everyone. Are there any recommended portable and lab spectrometers for LAN applications? So the same ones that I mentioned in this webinar can also be used for LAN applications. There's actually ASD is one of them that comes to mind. There have been used for both for LAN and ocean. Ocean Optics, they have a smaller, less costly version, which is typically, I think this one is, it's quite small. It's a few inches small, a few inches large, and it's connected at all times to a laptop, so it's definitely not for bringing underwater. Um, the one again that we use, the 1500 and its later versions, can be used on land and underwater targets. And like I said, there's a few of them out there. It's a matter of your project budget and the specific hypothesis or questions that you wanna answer. Okay, I'm gonna go with number 26, and then we'll call it the day. 27 is the same one that we mentioned before about the use of drones. Um, and 28 is same one as pretty much the same one as 26. The different species of seagrass can they be identified with hyperspectral data? I'm in a project monitoring seagrasses in Campeche, in Mexico. But there isn't very much data besides multispectral. Most times with seagrass species, based on my experience, it's really, really hard to distinguish them spectrally. They are extremely similar spectrally. If, let's say you're comparing Thalassia versus Syringodium or others, they're very, very similar. So they can be distinguished from some types of macroalgae, let's say from brown algae or red algae, obviously, because they have completely different pigments with field data. But when you're considering hyperspectral data with satellite or airborne images, this is also where spatial resolution in particular comes into place, because if they're just sparsely located in your area, there's going to be most likely the pixel is going to be a mixed pixel with both components at the same time, and then you have to do spectral mixing and unmixing analysis and things like that to try to separate the different components. But that's a little bit beyond the scope of this webinar. Um, but those are the things to consider. Generally, I would say no. Seagrasses are extremely similar in spectral terms, and they're really really hard to distinguish between them. All right, we're a little bit over time, so I wanna thank you all for participating in this webinar series with us. Definitely thank my colleagues and friends Amber and Zach for helping with this and for teaching some of the sessions as well. And again, if you have any questions, additional questions, feel free to email Amber or Zach or myself to the emails that are on the Q&A document and also on the presentation. And I want to thank the whole team behind the scenes that are actually the ones that do the magic, so that we can give you guys this webinar series and all the others, and also our our program director, Dr. Ana Prados, as well for her support on the NASA capacity building program. All right, well, thank you guys. I hope this has been useful. And stay tuned for the next ones. There's a few other RSET webinars out there that are pending in the next months, and stay tuned for them, because a lot of different very interesting topics are coming your way. All right. Have a great day, great week. Stay safe, and take care of yourselves.